Hello viewers, in today's session we are going to discuss another important and conceptual problem from definite integrals. And in this session we are going to discuss this integral in which we have to evaluate this definite integral from pi by 2 to 3 pi by 2, and our integrand is the square root of 1 minus sine square x, right? So this integral is going to be a very interesting integral because here we are going to apply the concept of mod function, which is also known as absolute value function. So let us start. So let us quickly revisit the definition of mod function. Now see, mod of p is defined as positive p whenever p is positive, that is p is greater than 0, and mod of p is 0 whenever p is equal to 0, and mod of p is negative p whenever p is negative, that is less than 0, right? So this is the definition of absolute value of p. Now here let us first call this integral as I, and let us first look at this integrand. So here we have square root of 1 minus sine square x. Now from trigonometric identity we know that sine square x plus cos square x is equal to 1. So 1 minus sine square x can be written as cos square x. So here square root of 1 minus sine square x is now equal to square root of cosine square x. So now our integral I takes the form that is pi by 2 to 3 pi by 2, and here we have square root of cos square x and dx, right? Okay, so now see, the mod function is also defined as square root of p square, right? So here square root of cos square x can be written as pi by 2. Here we have 3 pi by 2, and square root of cos square x can be written as absolute value of cosine x, because if we take p is equal to cos x, then square root of cos square x is equal to mod of cosine x due to this definition. So here we have dx, and now let us consider the sign convention of trigonometric functions in the four quadrants. So here we have the quadrants. This is first, this is second, this is third, and this is fourth. So here we have 0, here we have pi by 2, this is pi, this is 3 pi by 2, and this is 2 pi, right? So here we have to integrate from pi by 2 to 3 pi by 2. That is, here we have pi by 2, and here we have 3 pi by 2. So we have to go like this, right? So it means we have to cover the second quadrant and the third quadrant. Now here we have the absolute value of cosine function. So let us see the sign convention for cosine function in these two quadrants, that is the quadrant second and quadrant third. So in the second quadrant the cosine function is negative, and in the third function also, third quadrant also, the cosine function is negative, right? So when we go from pi by 2 to 3 pi by 2, the cosine function is negative. So we can now write mod of cos x is equal to a negative of cos x, because cosine function is less than 0 when we go from pi by 2 to 3 pi by 2, or we can express this fact as when x belongs to the second quadrant or the third quadrant, right? So mod of cosine x is the negative cos x, because cos x is less than 0. So when we have p less than 0, then mod of p is negative of p. So here if we take cosine x as p, then mod of p is equal to negative of p, because p is less than 0. So now here we can write pi by 2 to 3 pi by 2, and here we have minus cos of x dx. So now we can easily solve this integral. We can take negative sign outside the integral sign. Here we have 3 pi by 2 and we have cos x dx. Now the integral of cosine x is sine x, and the limits of integration are from pi by 2 to 3 pi by 2. And here we have first we'll take 3 pi by 2. So here we have sine 3 pi by 2 minus sine pi by 2. So substituting the limits and taking the difference. So here we have sine 3 pi by 2, that is 270 degrees. So sine 3 pi by 2 is the negative of 1. And here we have sine pi by 2, which is plus 1. So we have minus, here we have minus 1, here we have minus 1. So this is minus, minus 2. So minus and minus, it becomes plus. So we have 2, right? So the value of this integral is plus 2. So viewers, let us consider one more problem, and here we can change the limits, right? Suppose instead of having pi by 2 to 3 pi by 2, if we have this integral, that is, suppose I is equal to 0 to pi, and here we have square root of 1 minus sine square x dx. So let us consider the case when the lower limit is 0 and the upper limit is pi, right? So here we have to go from the first quadrant to second quadrant, right? We have to go like this. So here in the first quadrant, we can see that the cosine function is positive, and in the second quadrant, the cosine function is negative. So now we can write this integral as 0 to pi, and here 1 minus sine square x can be taken as cosine square x, and here we have dx, right? So square root of cos square x is the absolute value of cosine x. So here we have 0 to pi and mod of cos x dx, right? So we have just discussed that in the first quadrant, all the trigonometric functions are positive, right? So here cosine function is positive, and in the second quadrant, the cosine function is negative. So what we have to do here in this case, we have to split the limit at this point, or we have to break the integral at this point, that is x is equal to pi by 2, right? So we have to write like this, 0 to pi by 2, and then we have pi by 2 to pi, and here we have dx, here we have dx, and when we go from 0 to pi by 2, here we have mod of cos x, and when we go from pi by 2 to pi, we have mod of cos x, right? So here the sign of cosine function is changing from positive to negative as we traverse from the first quadrant to second quadrant, right? So when x belongs to the interval that is 0 to pi by 2, then mod of cos x is positive cosine x, right? And when x belongs to the second quadrant, that is pi by 2 to pi, then a mod of cos x is the negative cosine x. So here we can now write 0 to pi by 2. Here we have positive cos x dx, and here we have pi by 2 to pi, and here mod of cos x is negative of cos x dx, right? Because in this case cosine x is greater than 0 for all x belonging to this interval, and in this case cos x is less than 0 when for all x belonging to this interval. So now it is quite easy to solve these two integrals. The integral of cosine x is sine x. Limits are from 0 to pi by 2. Here we can take the negative sign outside, and the integral of cosine x is sine x. And here we have pi by 2 to pi, right? So here substituting the limits and taking the difference, we have sine pi by 2 minus sine of 0, and here we have sine of pi minus sine of pi by 2. So here sine pi by 2, that is sine 90 degrees, is 1, sine 0 is 0, and sine pi is 0, and sine pi by 2 is 1. So we have 1 minus 0 is 1 minus minus 1. So this is 1 plus 1 is equal to 2, right? So the value of this integral is equal to plus 2. So viewers, this is how we can solve these type of integrals by using the definition of absolute value function. So here especially this form of the absolute value function is utilized, and we have seen that mod of p is equal to square root of p square, and here square root of 1 minus sine square x is equal to square root of cos square x, which can be written as mod of cosine x, right? And using the sign convention of the function cosine x in different quadrants, we can arrive at the desired result.